So once again, good afternoon all. And today we will be continuing with the chapter motion, which we were discussing in the offline class, and it will be continued today also. Now, in our last class, we have just started the distance time graph, but before going into the details of the class, let me ask you a few questions. Uh, what do you mean by a distance time graph? Just raise your hand so that I can unmute you. What do you mean by the distance time graph? What do you mean by distance time graph? Okay, Hanshika, you can unmute yourself, Hanshika. First, you have raised your hand. Okay, Hanshika.
Yes,
Yes, Hanshika.
hello.
Yes, Hanshika, go on.
Yes, sir. Distance time graph is a graph in which time is plotted on the x-axis and distance is plotted on the y-axis.
Y-axis. Okay, fine. So if we are saying the distance, yes. So in the distance time graph, we can see the time is plotted along the x-axis and the distance is plotted along the y-axis. Now, here we have generated or we are supposed to talk about the three cases. The first case, that when the body is at rest, though we have discussed in our offline class, but I'm continuing from it. In the when the body is at rest, that means suppose the body is stationary or at rest at the distance of 10 meter from the origin. We are just hypothesizing this. Just we are considering this situation that starting from the rest, suppose the body has attained the distance of 10 meter from the origin, and now the position of the body does not changes with time. That means its distance from the origin continue to be same at all instant of time. That means at the duration of the 1 second, at the duration of the 2 second, at the duration of the 3 second. So each and every time the distance is the same, that is 10 meter. So when we are plotting this, we are getting a straight line parallel to the x-axis. So this is the case when the body is at rest. The second case, when the body is in uniform motion. For the body in the uniform motion, let us first depict one data where the time which is to be plotted on the x-axis 0, 1, 2, 3, 4, 5 seconds, and just a moment, someone, yes, waiting list, okay. Yes, and the distance with the advancement of time with every 1 second, the distance of the body is changing by 20 meter. When the time is 0, the distance is also 0. When the time is 1 second, distance covered is 20 meter. When the time is 2 seconds, the distance covered is 40 meter. When the time is 3 seconds, distance covered is 60, and so on. What you can see in this data, that for every second, the distance is changing uniformly. And what is the difference? That is 20 meter. 20 meter is the difference. So this is the case of uniform motion, because when the body covers equal distance in equal interval of time, it is said to be the uniform motion. Now, in this, from this very graph, till this we discussed in the offline class, and I told you during that day we ended our class that from the distance time graph we can determine the speed of the body. Here there are two possible ways. We can yes, all of you, just a second. All of us, let us, all of you, look to the graph properly. Okay. Now, in this graph, on the x-axis, the time is plotted 0, 1, 2, 3, 4, 5 seconds like this. And on the y-axis, the distance covered is plotted. You can see 0, 20, 40, 60, 80. And when we plot, suppose when the body is covering 20 meter with 1 second. So here we are getting the point. Like this, all the points are generated. The body covers 40 meter. After again the time interval of 1 second, the body covers 60 meter at the time interval of 3 seconds. Then again 80, this so on at the time interval of 4 seconds. Okay, this is the case. Now, when we are plotting this, we are getting a straight line originating from O, that is the origin, and this is a straight line OR. OR is the straight line. Okay, so directly if you are saying what conclusion we can arrive at it, that is when the body is in the uniform motion, we get a straight line. Okay, now from here, how can we calculate the speed of the object? Now see, for this, what we will do, there are, say, 1 minute. First, we will draw a line parallel to y-axis and parallel to x-axis parallel simultaneously. So first, let us begin with here. 1 minute. First, we will draw a line. First, let us consider a point A. See, first, let us consider a point A on the straight line. You can see the point A on the straight line. From the point A, we will draw a line parallel to the y-axis. Okay. And let us consider another point B. Let us consider another point B on the straight line OR, and we will draw a straight line parallel to the y-axis. Okay. Now, from the point B, we will draw a straight line parallel to x-axis, which meets over here. And from the point A, we will draw a straight line parallel to x-axis, which will meet over here. Got it? Now, so on the y-axis, where the line meets, we name it as S2 and S1. And on the x-axis, just we can say more than 3 seconds, 3 seconds ahead, it is called T1 and T2. Till this is clear? Till this is clear to all? Through the chat box to give me the reply. Okay, I got one. Yes, Shreya, Anshika, Om Kumar, all the students. Soumya, okay, fine. Dipti, okay. Yes, I got all the reply. So now you see what we are going to do. Now, students, here T2 minus T1. Okay. Let me incorporate the text also. Here T2. Okay. T2 minus T1. Okay. What does it indicate? It indicates the time taken. Okay. T2, that is the final time minus the initial time. T2 minus T1. Do you agree? It is a time taken. Okay. Now, distance traveled. Distance traveled, definitely it will be S2 minus S1. Okay. Do you agree? T2 minus T1 is the time taken, and S2 minus S1 is the, just let me keep the chat box over here. Just a moment. Okay, fine. So this is the case. T2 minus T1 is the time taken, and S2 minus S1 is the distance travel. So what will be, what we know the formula of the, what we know as a formula of speed? Distance traveled by time taken. So can we say distance traveled by time taken is equals to t, just a, distance traveled by time taken, distance traveled is S2 minus S1 divided by T2 minus T1. Do you agree? All of you, do you agree? This we are going to calculate for the speed, total distance traveled by total time taken. Do you agree? Okay, let me unmute you. It will be better. Okay. Okay. Just a moment. Let me also give you the option to unmute yourself. Yes, now you can unmute yourself also. Whenever I will ask you, you can say. So that will be the distance traveled by the time taken. Is it clear to all?
Yes, sir.
Yes, sir.
Okay, fine. Now, S2 minus S1. Now see what we are going to do. We will join the point AC. We will join the point AC. Okay. Now see, S2 minus S1. S2 minus S1, can we say it is BC? Yes or no? S2 minus S1, can we name as BC? Yes or no?
Yes, sir.
And
Yes, sir.
T2 minus T1, can we name at CA? Yes or no?
Yes, sir.
So can we say the speed now becomes BC divided by CA? Yes or no?
Yes, sir.
Students? Okay. So from this very graph, that is a velocity time, distance time graph, when the body is in the uniform motion, we can calculate the speed of the object. Is it clear to all?
Yes, sir.
Yes, sir.
Okay. Okay, fine. Now, students, for regarding this, the writer part I will send in the class of WhatsApp group. Okay, so no need to worry for that. Now we are coming to the third situation. That is when the body is in non-uniform motion or accelerated motion. I will ask a question to all. Okay, let me ask Soumya. Soumya, what is a accelerated motion, Soumya? Try.
Sir, it is defined. Yes, sir. It is defined as rate of change of velocity of the body with time.
Rate of change of velocity. So in accelerated, will it increase or will it decrease?
Uh, increase.
Increase, very good. Now see the data. Value of time and the distance in uniformly accelerated motion. Here you can see the data are depicted over here 0, 1, 2, 3, 4 and 5 seconds, and the distance is also depicted 0, 5, 20, then 45, 80 and 125. Now let us plot this. When we are plotting this all data, we give what we get in the, when the motion of the body here, we are getting, just a moment, let me use the graph data. Yes, just a, yes. When we are plotting all the values, we are getting a curve like this. So this indicates the body is in the uniform accelerated motion. Okay, but on the same time, when the motion is in retarded, we can see from this graph, we can see from this very graph. See, altogether, student, this graph will show you all the three possibilities. First is when the acceleration is zero. That means the body is under uniform motion. This we have already done in the last graph. Now, this graph indicates that the body is in the positive acceleration, that means accelerated motion. And when the body is in retardation, that is negative acceleration, it will bend like this. Is it clear? To from this very graph, we can get all the three graphs. The idea of the three graphs, that what happens when the acceleration is zero, it will be a straight line passing through the origin. Positive acceleration, it will be a curve, and negative acceleration, it will be bending towards the x-axis. Is it clear to all the three possibilities? The three distance time graph is clear to all?
Yes, sir.
Yes, sir.
Now, I will ask at least the three possibilities and the three situations to one by one. First, let me start with Dipti. Dipti, unmute yourself.
Yes, sir.
Dipti, what type of graph we get when the body, distance time graph we get when the body is at rest?
Sir,
When the,
parallel to the x-axis.
parallel to the x-axis, okay. The next, let me ask just, yes, Gia. Gia, unmute yourself, Gia. Gia, unmute yourself. Yes, Gia, unmute yourself. I have given you the option. You can unmute yourself by your own. Gia. Unmute yourself, Gia. Okay, I think not audible. Okay, Divyanshu. Okay. Okay.
Yes, sir.
Divyanshu, what type of graph, distance time graph we get when the body is in uniform motion?
Sir, the speed will increase.
Uniform motion, I am saying. What type, what will be the nature of the graph?
Sir, the body is continuously moving in a same motion.
Same motion, then it will be a straight line from the origin. Okay. Next, Kanak Kumar. Unmute yourself, Kanak.
Yes, sir.
Kanak, what is retardation, Kanak?
Sir, negative acceleration is called.
Negative acceleration. Okay. What type of graph we get, Kanak, when the body is in the negative acceleration, or that is a retardation?
Sir, uniform motion.
No, no, not uniform, Kanak. See, I am showing you on the background also. See, this is the graph. This is the graph. Yes, this is the graph.
Yes.
Okay. Is it okay, Kanak? Okay,
Yes, sir.
fine. Okay. Now, student, the three cases of the distance time graph, we have come to the conclusion, and now we will be doing the velocity time graph. Now, see, the velocity time graph, the very important and conceptual also, the velocity time graph. Now, the velocity time graph, on the x-axis, we are plotting the time, and on the y-axis, we are plotting the velocity. When the body is moving with a uniform velocity, you can see uniform velocity. As the velocity of the body is uniform, neither its magnitude or direction changes. Therefore, the height of the velocity time graph will remain the same at all instant of time. You can see here in this very image, the height. That means a height. This is the height. With all instant of time, 1, 2, 3, 4, 5, it is remaining the same. So we get a straight line parallel to the x-axis. Now remember student, from the velocity time graph, we can calculate the displacement or the distance covered by the body. So now we will study how it is possible. So see, at any time, we are drawing, say, a point called A on the x-axis and a point B again on the straight line which was parallel to the x-axis, a point C on the x-axis and a point D on the straight line parallel to the x-axis. So can we say OA to be T1? This is a time, yes or no? We are saying OA to be T1 and the velocity V is equals to, this is the velocity AB. AB is the velocity. And what is the time? Time is the, OA is the T1, the time. Yes or no? Now at another time,
Yes, sir.
at another time, what is another time? T2. We will say T2 is equals to OC. Okay. And what will be the velocity? Velocity? Any guesses? As for the time T1, we are saying the velocity AB. So at the time T2, what will be the velocity?
CD.
BD.
Very good, CD. And now can we say, since because it is a square, so CD is equals to AB? Yes or no?
Yes, sir.
Here it is, okay, the two sides are equal. Now because of the fact that now area of the rectangle, okay, since because it was a rectangle, we are talking about the two sides. Now the area of the rectangle ABCD, because bounded by the four side, area of the rectangle ABCD, what it will be? Length into breadth. What is the length? What is the length? Length is the AB and AC is the breadth. Do you agree? Let me erase the fact. See, area of this is a triangle ABCD. Okay, this is the total area of the triangle. So area of the triangle will be L into B, length into breadth. So what is the length? That is a AB into AC. Do you agree? AB into AC.
Yes, sir.
Now you see, can we say AC for AC? Can we say AC is equals to, just a moment. Can we say AC is equals to, is equals to OC minus OA? Do you agree? Do you agree or not? AC is equals to OC minus OA.
Yes, sir.
Yes. Now, students, we are knowing the value of AB. What is the value of AB? AB is the velocity V, and OC is your T2 and OA is your T1. So what we are getting ultimately we are getting over here, just again, let me use the pen. Okay. Again, now see. Yes, this one. So is it clear to all that how we can get the magnitude of the displacement? Now the magnitude of the displacement moved by the body is equal to the area enclosed by the velocity time graph and the time axis. So the area enclosed, this is the magnitude, that is the total area of the rectangle ABCD where the sides are equal. And so this total area, when we will find the total area, then we can find the magnitude of the displacement. Should I repeat once again? Or is it clear to all? Reply. Yes, don't hesitate through the chat box. No, yeah, you can unmute yourself. Yes, Dipti, Soumya, Kanak. I've given you the option to unmute yourself. Okay, Dipti. Okay.
Sir, repeat.
Okay, Dipti. Okay, fine. Once again, as yes, I'm repeating once again. See, in this graph, let me use it. In this graph, 1 minute. Let me highlight it. In this graph, we are about to find the magnitude or the distance moved by the body or displacement. So what we do, we plot a point on the x-axis, which is named as A, and we join that line of the straight line parallel to the x-axis, that is B. Again, we take a point time t2 and we join the straight line parallel to the x-axis at the point D. Now, here, now you see, so area of the triangle, area of the rectangle, sorry, area of the rectangle ABCD, length into breadth, AB into AC. What is AB? AB is equals to V. And what is AC? For getting AC, we can say AC is equals to OC minus OA. What is the value of OC? Tell me, what is the value of OC? What is the value of
T2.
OC? Soumya, what is the value of OC?
That's T2.
T2, very good. And Kanak, what is the value of OA? Kanak, what is the value of OA?
T1.
Okay, very good. So we can say now what will be the magnitude of the displacement? V into the time difference. That is V. If you are knowing the value of V, here V is 10, and the time if you are knowing, then T2 minus T1 we can get from here. Now is it clear to all? Dipti, is it clear now?
Yes, sir.
Okay, fine. Now, student, let us come to the second situation of the velocity time graph. That is when the body is moving with a uniform acceleration. Here again, you see, it is very similar to the previous graph. Let me zoom out. Here, the data for this is given 0, 5, 10, 15, 20, 25. These are the data in seconds, and the velocity is also given over here. When we plotted them, we get a graph of a straight line. Now in this also, now let us start from here. From this graph also, we can calculate two very important things. One, we can calculate the acceleration of the body, and also we can calculate the distance traveled by the body. How it is possible? See, for this, what we will do, let us first focus at how we can calculate the acceleration. So what is the nature of the graph which we get when the body is in the uniform acceleration? That is, we get a straight line. This is very similar to that we have done in the distance time graph also. So what is the acceleration, or how the acceleration can be calculated? For this, what we are doing, we are taking a point on the x-axis as A and a point on the straight line B. Okay, another point we are taking on the x-axis as C. See my pen. Okay, just a moment. First, we are taking a point A on the x-axis, B on the straight line, C on the x-axis, E, and then see, this is the point D on the straight line. Now, see student, again we will be using the previous one only. Okay, previous formula only. See, time T1. What is the value of T1? What is T1? Here in the diagram, you can now see it is the T1 is hidden. But tell me, what will T1?
OA.
Very good. That is the first. Yes, correct. OA. OA. And what will be T2? Quickly.
OC.
OC.
Very good.
OC.
OC, correct. OC. This is T1. This in the last graph also we have seen. This is T1 and this is T2. This is T2. Okay. Now see, this is the called the slope of the graph. Okay. And it is a student, have you done in the trigonometry the tan theta? In trigonometry, you have done tan theta
No,
till now? No, no. Okay, no problem. It is tan theta is equals to, see, this is called hypotenuse of a triangle. Hypotenuse, this is the opposite side, and this is called the adjacent side. So, perpendicular by base. The formula is this, perpendicular by base. We get a slope of the graph with the formula dE by BE. That is perpendicular by base. This is a perpendicular. DE is the, let me clear the drawing first. DE is the perpendicular and BE is the base. So if we are knowing the value of DE divided by BE, then we can get the slope, and the slope of the graph gives us the value of the acceleration. Now, how the slope of the velocity time graph can be calculated? dE by BE. Now, let us see what is dE. Now, dE is equals to, see, I'm writing over here also. dE is equals to CD minus CE. Do you agree? Okay, let me
yes,
shift.
sir.
Yes, sir.
Okay. And what is BE? BE, can we say it to be AC? Can
Yes,
we
sir.
say? Yes, okay. Now see,
Yes, sir.
CE is equals to, let me draw this. Just a moment. CE, see this. CE, can we say CE is equals to AB? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now, and AC we know, OC minus OA. So CD minus AB, what is CD? CD is equals to, let me again clear the drawing. CD is equals to, this is CD, this is total. CD is equals to V2 and AB is equals to V1. Okay, so V2 minus V1 divided by T2 minus T1, that is the acceleration. Student, remember in NCERT, tan theta is not given. Okay, directly they have given that V2 minus V1 by T2 minus T1. Okay, this is extra which I'm telling you. So from this very graph, we can calculate the acceleration of the body also. V2 minus V1, final velocity minus initial velocity, and definitely the final time minus the initial time taken. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Now, okay. Actually, too many calculations have been done. Till this, any doubt? Otherwise, no, not today. Distance traveled by the body from this very graph only, this I will be doing in tomorrow's class. Now, till this, anyone having any doubt or any portion you want to get revised so that your doubts may be clear? So 2 minutes are left, because distance traveled by the body, I will be doing tomorrow. From this very graph only, the distance traveled by the body, we will be doing in our next class. And then the velocity time graph will be over, and tomorrow we will be starting the equation of motion also. Remember, student, the derivation of the equation of the motion is not there in the syllabus. That has been deleted. So we will do the equation of motion, and after that we'll progress to the numericals also. Till this, I will send the class work in the class WhatsApp group also. So till this, if you have any doubt, you can share. Okay, so thank you students for today's class.